Hello, grade 12. So we're continuing with example 3 and 4 now with the right angle triangle theorem. Okay. So with this question, they're saying in triangle ACD, the big one, we have that CD is perpendicular to AD. So I'll just mark that in. And BD, this one here, is perpendicular to AC. I'll mark that in there. And we know that AB is equal to 2 times BC. Okay, I just want to try to get this into a ratio. So we get AB divided by BC. BC is equal to 2 to 1. Okay, so we have a ratio going on there. Now, the first question is asking us, express CD in terms of BC. So CD in terms of BC. All right, so I just want to get this proportion in here. We know that AB is 2, and we know that BC is 1. Okay, and just like the other one, I'm just going to put in a K. All right, so you can just see what I'm doing here. So I know that CD, because we can use our right angle triangle theorem here, I know that CD squared will be equal to CB times CA. Okay, so CD squared will be equal to CB times CA. And my reason for that is perpendicular from right angle vertex. Okay, and you can see why I've done this, because we have our CD, there's our CD, and we have our BC is there. Okay, so I now know that CD squared will be equal to this CB times now CA in terms of BC. So we can see here that CA is 3 parts and BC is 1 part. So that means that CA, this one here, is equal to 3 times BC. Okay, just because we've got 1 part to 3 parts. Okay, now you're probably asking, why am I not bringing in the K this time for this example? It's because this is in terms of K and these are in terms of K. All right, I'm not bringing any type of unit length into this ratio. Okay, so I can now simplify this and we can get CD squared is equal to 3 times BC squared. Take the square root and we get CD is equal to root 3 BC. So we've got CD in terms of BC. This was question A. Question B is asking us, find the length now of DA if CD is 4 centimeters. So we now know what CD is. It's 4 centimeters. Okay. Now, I am going to use this over here. We know what our CD is, and I'm going to find the BC. The CD is 4, and I can find BC. Okay, but I know what you guys are going to say, but why am I not using the K? Because the K was cancelled over here. All right, this would have given us a K squared, because they're the same. We would have had a K there and a K there. This would have also had a K. They would have been 3K. So the K squared would have cancelled with this side, and that is why we can use it like that. Okay, so I know what CD is. It's 4 is equal to root 3 BC. That means that BC is equal to 4 over root 3. Okay, that means now I can find the length CA. Once I've got the length CA, I have the length CD. I can find AD using Pythagoras. Okay, so therefore CA is equal to, now CA is equal to 3 times BC, and we have what BC is. So this would be equal to 3 times what BC is, which is 4 over root 3. You can put that on a calculator and you can calculate that CA is 4 root 3. Okay. Now I'm going to use Pythagoras. So we know that DA squared will be equal to AC squared minus CD squared. And my reason for that is Pythag. I can substitute my values in. So AC is this 4 root 3 squared minus CD is 4 squared. Put that on the calculator and you will get that DA is equal to 4 root 2. Okay, and that's the solution for that one. Moving on to example 4. Okay, so example 4 is saying in triangle ACD, in ACD here, we know that AC is perpendicular to CE, and then it tells us that DC is perpendicular to AE, so this is 90. And then DB, this one here, is perpendicular to AC. We have to prove two things, that CD squared is equal to AC times BC, and question B, BC is equal to AB times DE over AD. Right, let's have a look at question A. So CD squared, CD is over here, CD squared, AC, BC. Okay, so that looks like if this is 90, grade 12s, that means that this is also 90, angles in a straight line, okay? So I'm working with this little triangle here, this ADC triangle. I have my main 90 degrees, and then I have it coming off with another 90 degrees. That means by the right angle triangle theorem that this squared would be equal to this times this. And I think pretty much that's what they wanted. So we know that CD squared would be equal to BC times CA. And that's exactly what they wanted. Okay, so perpendicular from right angled vertex. Pretty easy. Okay, question B. Now with this one here, this BC, I'm just having a look at what I have. So BC, AB, DE, and AD. That looks like line parallel one-sided triangle because I have this over this equals this over this. That was all of these little things that I just picked out there. So if I can prove that this line DB is parallel to this line EC, I can use my line parallel one side, okay? But I think we pretty much have proved that already because that is 90 and that's 90, therefore these must be parallel, okay? So let's just say that. Let's put in some values here. Let's say B1 and B2, okay? This is obviously 90 degrees. So what I can say here is I can say that B1 is equal to angle C. That was given to us. Okay, there's nothing to prove there because they said that the lines were perpendicular. That means, therefore, that this DB line is parallel to this CE line. And my reason for that is I can use corresponding. Corresponding angles equal. Okay, now that means because this is parallel to this, maybe let me just highlight it for you so you can see. I have that this over this will be equal to that over that. Okay, so let's state that. So we know that AB over BC will be equal to AD over DE. And this is line parallel one side triangle. And I just want to state the parallel lines, which was BD parallel CE. Okay, so let's try and get what they want here. They want the BC on its own. So if I multiply up by the BC, multiply up by the DE, divide by the AD, we have that. So multiply up by the BC is equal to, the AB will still be up at the top, multiply up by the DE, and then divide by the AD. And we have what they want. Okay. So grade 12s, what I'm going to do now is I'm going to skip Pythagoras' theorem. Okay, you guys know what Pythag is. We've used it how many times since grade 8? Okay, so you can just have a look through that theorem and stuff, but I'm not going to go through it. I'm not going to go through example 1 next, or example 2 next, or example 3 next. I will give you the solutions to that because it's just using your Pythag. Okay, we know how to use Pythag. So what I would like you guys to do is exercise 8 for me, please. Thank you.